Hi, everybody. I want to go through a quick example of how we might do the calculations to do a regression coefficient and the R square and the standard error of the regression or the residual standard error. Pretty straightforward. So we have in front of us some data. We have 5 observations on temperature and 5 associated observations on ice cream sales. So when the temperature is 80 degrees, sales are 10. When the temperature is 93 degrees, sales are 23 higher, right? So to calculate the regression coefficient, we're going to use our standard formula. Beta 1 hat equals x minus x bar, y minus y bar divided by x minus x bar squared. Pretty straightforward. And then our intercept, beta 0 hat, is going to be equal to y bar minus beta 1 hat times x bar. So to calculate beta 1 hat, we need to first calculate x minus x bar, then x minus x bar squared, then y minus y bar, then x minus xy minus y bar. Then we need to use the summation sign to, right, we need to add them all up. So x minus x bar, well, we first need to calculate the mean of x and the mean of y. We get 86 and 16. Then we calculate x minus x. So 80 minus 86 is minus 6. 85 minus 86 is minus 1. 82 minus 86 is minus 4. 93 minus 86 is 7. So we do that for the x's. Then we square each of these terms and we get this, pretty straightforward. Then we calculate y minus y bar. So y bar is equal to, the mean of y is equal to 16. So 10 minus 16 is minus 6. 12 minus 16 is minus 4. 15 minus 16 is minus 1. 23 minus 6 is 7. And then we multiply x minus x bar times y minus y bar. Minus 6 times minus 6 is 36. Minus 1 times minus 4 is 4. Minus 4 times minus 1 is 4. 7 times 7 is 49. 4 times 4 is 16. Then we add these up. That gives us x minus x bar, and that's 118. And we add these up. That gives us the sum of x minus x bar, y minus y bar, and that's 109. So that's roughly 11 over 12. So that's roughly 0.92. If we had a calculator, we could have a more exact thing. For manual problems, we're just approximating, so it's fine to round. Once we have beta 1 hat, we can put it in here, 0.92 in there. Y bar is 16, x bar is 86. So we calculate beta 0 and we get minus 63. So now we have our estimated equation. Beta hat 0 is minus 63 and beta hat 1 is 0.92. So now we can go and calculate predicted values of y. So we've estimated our best fit line there. Our data are around this best fit line, right? These 2 points are below. I drew it, it's not exactly to scale, but it's close enough. These 2 points are below, and these points are above the line on the vertical scale. So we can calculate our predicted y. So here's our predicted y, and then we can take the difference between the predicted y and the actual y. So for value x equals 80, we have up here, right? The actual y is 10. So here's the actual y. The predicted y is 10.6. We calculate that here, right? We put 80 into here. So this xi is 80, and that gives us a predicted y of 10.6. The difference is negative 0.6. We do that for each observation. We calculate the residual, the error. Then we square all of those and add them all up, and that's the sum of squared residuals, right? The sum of squared residuals. We also might calculate the total sum of squares here, and that gives us our R-square formula. One that enables us to put those numbers into the R-square formula, which is 1 minus the sum of squared residuals divided by the total sum of squares. So that equals 1 minus 17 over 118. So that equals about 0.86. Then we can also calculate the standard error of the regression. It's the square root of the sum of squared residuals divided by n minus t. The sum of squared residuals we calculated here is 17. So 17 divided by 3, square root of that is about 2, right? 2.3, something like that. We could go over to R to check our answers. So we can type these into R. So here's our two vectors. Then we'll turn them into a data frame. Then we'll run the regression. Then we can literally do all the calculations we just did in R. You can see how it is. Just copy these commands. We're going to create the predicted y, then the residual is the difference between y and the predicted y, then the residual squared, then we add up all the residual squared, and then we take the square root of 17 over 3. So it's a lot easier to do this in R. So that's basically the kinds of calculations everybody who's learning regression analysis with just one variable, this is what basically you need to know.